Welcome to the lesson, How Does Matter Change? You'll explore how chemical and physical changes are affected by temperature. The vocabulary words for this lesson are chemical change, reaction, and physical change. Remember what you learned about boiling? Now, think about what happens to food when it cooks. Where in this photo do you think a chemical change is happening? Select the part of the photo that best answers the question. You got it! Matter can change in two ways. Click the pictures to learn more about physical and chemical changes. When a chemical change happens, the particles that make up a substance change into new types of particles. They have different properties, like tastier toasted bread. How can you tell when a chemical change is happening? Look for temperature changes, changes in color, light and heat being given off, or bubbles forming. Burning candle wax is a chemical change that gives off heat and light. Physical changes result in different physical properties, such as size, shape, or even a substance's state. They don't change the substance's identity. Some examples of physical changes are cutting and bending. If you tear up a sheet of paper into smaller pieces, each piece is still made up of paper. It doesn't turn into plastic. Matter doesn't change identity when it changes state. The type of particles that make up a substance are the same, whether it is a solid, a liquid, or a gas. So, melting and other changes of state are physical changes. The speed of chemical changes often depends on the temperature. Click the play button to see the effects of temperature on cooking. A reaction is what happens when one substance is changed into another. Reactions start at different temperatures, and many only occur at certain temperatures. When you increase the temperature of food enough, it will cook. Increasing the temperature often makes reactions happen faster. For example, when you use hotter temperatures to cook food, it will cook faster. Adding thermal energy to chicken causes it to cook and turn brown on the outside. But if the heat is too high, the chicken will burn instead of browning. Now let's take a look at how adding heat to something can increase the rate of a reaction. We'll use an iron scrubbing pad and see how quickly it rusts in a mild hydrogen peroxide solution. Click the first image to begin. First, we need to see how quickly the scrubbing pad rusts in the peroxide solution at normal temperatures. We do this by adding the scrubbing pad to a beaker and then carefully adding our peroxide solution. We then monitor the flask over a period of time, checking to see how quickly it rusts. As we expect it to be slow, we might check every 15 minutes or so. Now, let's repeat the experiment in exactly the same way, but this time we'll do it on a hot plate. Adding heat to the beaker should increase the reaction rate and cause the pad to rust quicker. As you can see, the pad has turned brown as the iron in the pad reacted faster with the hot peroxide solution. So, we have proven that adding heat can increase the rate of chemical change. Temperature changes can cause changes in physical properties. Click the images to see more details. Higher temperatures make gases less dense. That's why hot air balloons are buoyed up by cooler air. Temperature affects the volume of gases. When temperature increases, gases expand or take up more space. Lowering the temperature causes gases to contract or take up less space. Increasing temperature causes most solids and liquids to expand. These small changes can be hard to see, but they add up. This is why big metal and concrete bridges have special connections that allow the bridge to expand and contract without bending or cracking. You've probably seen some objects glow orange and yellow when they're heated. They're not burning because they're not changing into new substances. They're giving off light only because they're very hot. While matter is changing from one state to another, its temperature does not change. When water freezes or melts, it is at 0 degrees Celsius. When it is boiling or condensing, it is at 100 degrees Celsius. The flat parts of the graph line show when water is changing state. Do you remember the difference between a chemical change and a physical change? Sort each of these changes into the correct category. Sometimes it isn't easy to tell the difference when changes are happening. Here's one way to tell. After a chemical change, the matter's identity is different, like the difference in taste between cookie dough and a baked cookie. After a physical change, the matter's identity is the same. Melted cherry ice cream still tastes like cherry ice cream. Suppose you put half an apple in the refrigerator and leave the other half on a table. After an hour, the apple in the refrigerator is less brown than the apple on the table. Why? Choose the best answer. Good job! Lower temperatures can slow down many chemical changes. Apply what you've learned about temperature and physical changes to your own experiences. Describe a physical change that you've observed that depended on temperature. Type your answer in the box, then click OK. You've learned a lot about how matter changes in this lesson. Before we finish, let's take a quick look at the main points you covered. Now you know that physical changes, such as cutting an apple in half, affect the physical properties of matter. But they don't change the identity of the matter. A chemical change does change the type of matter. Chemical changes happen to a cake as it bakes. You also learned that changing temperature can cause physical changes, such as melting. While matter is changing from one state into another, its temperature does not change. Physical and chemical changes occur in all aspects of your life. They happen in your body and in your environment, not just in the kitchen. Now that you've finished this lesson, click the menu button to exit, or if you wish, you can go back and review any part of the lesson again.